Okay, so we're now in 2.3 and we're still part of the lesson. And this is kind of like a review of what you've learned in 2.1 and 2.2 and kind of putting it all together. So for each of these little cards, they wanted you to find the function and then some characteristics about that. So we're going to do 7 and we're going to do 9, I think. Yes, that's correct. Okay. So the first thing that I do is I look at the actual, what did they give me, right? And so if you look at what they gave you, it says a radioactive element decays at a rate of 5%. So what that means is it's almost like the Brownian example that I gave in a couple videos ago. So like we start off with a mass or a certain amount of something, and then it decays at a rate of 5%. So you'll see it, and then a little bit like a year later, you look at it and you're like, oh, it's smaller. How much smaller? It's 5% smaller, right? And so on and so on. So you can kind of see that this is again that exponential decay kind of graph where it starts off really big and then it swoops down and it never touches zero. So the scientists begin with 40 grams of the element, and the function is a model for the amount of the element remaining at a given time. So the domain of the function and whether the function is discrete or continuous. So remember that continuous means that the points are connected. Discrete means the points are disconnected. Discrete contexts were like people, or I think we did smiles one time, or you can think about bikes. You can have a whole bike. You can have parts of bikes, but you wouldn't call that, 2.2 bikes, right? So this reminds me of, because it's 40 grams of something, you can have different parts of the gram. Like you can have half grams, 2.2 grams, you can have all of those different pieces. So for me, this is continuous. Okay. And then they ask you for the domain. Now the domain of the function, if you think about domain, it's when you're looking at the graph and you look from left to right, what numbers are we not including? What numbers are we not including? And so because of this context, right? Because of this context, I notice that that we're not thinking about negative numbers. So the negative numbers is out, because negative 2 years doesn't make sense. It actually does kind of make sense. It's 2 years before they start measuring, right? But in this context, they want you to start at a certain time. And then you ask yourself, okay, well, what about the in-between numbers? Like I get year 1, year 2, year 3. Can we measure at like year 1.2, right? Like 1 year and 2/10 of a year. Can we do that? And it's like, yeah, you can measure, right? Because they have the given measurements and stuff. So here, I'm going to show you, we're going to say that X is all numbers greater than or equal to 0. Okay. And if you are trying to get fancy with set notation, it'll look like this. So curly brace X such that X is greater than or equal to 0. Now, in terms of you learning, oh, it's not catching up to me. Hold on a second. Yes, second. All right. So I wrote some set notation in here, and it'll show up pretty soon, I assume. Yeah, there it goes. So this is the set notation where we have a curly brace and a curly brace. This literally says X is such that X is greater than or equal to 0. This and this say the same exact thing. This is just called set notation. And you want to kind of understand what set notation is because whenever we're asking a question, you need to know what our possible answers could be, or what possible numbers we can plug in this case. And so I know this looks weird. Just get used to seeing it like, oh, curly brace. And every now and then try it. This is just a straight line on the top. It almost looks like a lowercase L. Okay, so the type of function, it is a geometric or exponential, whatever you want to call it. Actually, it's not geometric. I apologize. So exponential. Shelton, why isn't it geometric? It's not geometric because geometric tends to be a sequence, and discrete, this is continuous. So, and the difference or growth factor. So this is a growth factor, even though it's decaying. The growth factor is 5%. it's, going down 5%. So when I write my function, right, my function is going to have some version of a 5%. So I might come back to this and show you what the growth factor actually is, because we need to kind of convert this into a function that we can actually use, right? And so if I was going to write an equation, you guys have noticed that our equations, oh, you know what? I will write the recursive function. So f of 0 is going to be 40. And then f of n equals to f of n minus 1 times. Now, if I multiply it by 0.05, that 0.05 represents the amount that is gone. So I don't want to multiply by 0.05. I actually want to multiply by the rest of it, which if you think about the rest of it, that's 0.95, because that's how much is left. See, because it says the function is a model for the amount of element remaining. I don't care about how much is gone. I care about how much is remaining. So if this is how much is gone, then the rest of that is going to be the remaining. Does that make sense? So here, I'm going to write this as my growth factor is actually 0.95 because the 5% is being decayed off. Okay. All right, and the second problem that they wanted was number 9, which is here's your given function. And it says do the same exact thing. So let's see, the given function is this. Is it discrete or continuous? Can you tell if it's discrete or continuous? And you guys are like, yeah, Ms. Johnson, it's connected. Therefore, it's continuous. Very good. And then the second part is, can you tell me what the domain is? Well, I told you when you look from left to right, are there any values not included? And it looks like all numbers are there. So then our domain would be all real numbers. And so if you're trying to do set notation, there's a couple different ways that you could do set notation. But the way that I like doing it is X such that X is an element of the real number set. So a couple of different symbols here that you're learning. You know the capital R with the fancy stick, that's the real numbers. This E, like a funky E looking thing, it means is an element of. So X is in the set of. X is an element of. I picked a number from the real number set, every single number, right? That you know right now. Now, next year, when you get to integrated 2, there's another set of numbers that you will learn, okay? And then do you want to write the function for, oh, let's do this one. It says the type of function, this is linear. I don't know why I'm using my fancy glitter pen, but there you go. And then the difference or the growth factor. So I'm going to find the slope of this thing and then do that. I am going to find good points. So if you zoom in really well to your graph, you're looking for good points. And a good point is like this. It goes through the cross. So I'm going to go along this line here and I'm looking for another good point. And I can't see on that. So I'm going to look at my own little graph here. I don't see. Oh, this kind of looks like a good point right here, because I'll see like wherever this point is right there. So I'm gonna put that point there. Because my graph is really, really small, I'm just gonna assume that's a really good point. If I'm wrong, that's okay. All right, so now I want to find the slope of this guy. So I'm gonna count how much I went up. So this looks like it's going up by 2s. So from 2 to 40. That's 38. So my slope, let's do that. Rise is 38. And then the run, this looks like it's 22, 24, 26 over 26. So this is 19 over 13. It looks like a weird slope. This is like a really weird slope. And then my slope is negative because it's going down, down, down. So there goes my slope. So I'm going to write my equation as y equals mx plus b. And if you got a different slope because you didn't, you found a better set of points, because this is so small of a graph, I wouldn't penalize you. So this is negative 19 over 13 x plus, now b is my y-intercept, so that's just that guy right there. So that's plus 40. Good. All right. So the biggest deal here in terms of these two problems, can you tell the difference between discrete and continuous? And can you tell if it's linear or exponential? Can you find me a growth factor? In this case, it was called the slope, and then give me another representation. Very good.